Welcome to our lesson on the integral part function, also known as the floor function, a fundamental concept in mathematics that helps us understand how real numbers relate to the nearest integers below them. Often denoted as x, this function specifically means finding the greatest integer that is less than or equal to x, ensuring it never exceeds the original value. Let's consider the function f(1) x within the range from just after 2 to 2, inclusive of 2 but exclusive of 2, so 2x 1 counts 2, to observe its step-like behavior clearly. For any x value where 2 x 1, such as values approaching 2 from the right or like 1.8, the function f equals 2 throughout this entire interval. This means that for any number in this interval, like 1.5 or 1.2, the greatest integer not greater than it is 2, as it rounds down to the integer below. Next, for x values where 1 x is or 0, including points like 0.9 up to just before 0, f becomes 1 consistently across the intervals. Consider 0.7 or 0.3. The greatest integer not exceeding it is 1, clearly demonstrating the function's downward rounding behavior in this range. Moving on, when 0 goes to x, 1, covering non-negative fractions up to but not including 1, f evaluates to 0. For example, if x is 0.5 or 0.8, the greatest integer not greater than these values is 0, showing the flat step here. Then for x values where 1 x 2, such as 1.1 to 1.999, f is 1 throughout this segment. If x is 1.9 or 1.3, the greatest integer not greater than 1.9 is 1, illustrating the consistent value in the open-ended interval. Finally, when x is exactly 2, which is included in our domain, the function f equals 2 precisely at that point. This is because 2 is already an integer, so it is the greatest integer not greater than itself, with no rounding needed. The integral part function, or greatest integer function, creates a distinctive step-like graph, where the value remains constant between integers and jumps up at each integer point. Understanding this function is crucial for advanced topics in calculus, discrete mathematics, and analyzing piecewise constant behaviors. It helps us analyze real-world situations where quantities must be rounded down to the nearest whole number, like flooring prices or counts. From calculating shipping costs based on weight tiers to determining floor ages in demographics, the integral part function has practical real-world applications in everyday computations. Keep practicing these concepts with more examples and graphs, and you'll master the integral part function in no time.